Good morning. I'm Mark Reinhold. Brian Goetz, my colleague, will be joining me in a little bit. We are going to talk about Java 9 and maybe some about what might be in 10, 11, 12. We're not sure. We're not making any commitments beyond what is going to be. 9 has a lot of features in it. There are some features, believe it or not, that don't involve Jigsaw. What do we have? We have variable handles, var handles. We have compact strings. We've got, we're taking away SHA-1 certificates. Those are not a good idea to use anymore. We even have, for those of you who really want it, an S390 port for Linux. Who's been waiting for that? Well, anyway, a lot of people are actually really psyched. Bean info annotations, OSCP stapling. We apparently have both Unicode 7 and Unicode 8. Yeah, we've been working on this release for a while now, haven't we? So lots of good stuff that doesn't involve Jigsaw. I want to show you one particular thing that is sort of the sleeper feature of the release, JShell, the read-eval print loop for Java. Now, let me see if I can switch to this box. Yay, and actually show a demo. So here I have a freshly minted JDK 9 build. It's actually the Jigsaw prototype build. I built it on this very machine just a couple of days ago, so it's got all the latest goodness in it. JShell, I type JShell, and it starts up. JShell is an interactive Java shell. You type little snippets of Java code at it, and it evaluates them in real time and tells you the result. It doesn't need to ask IBM Watson or some Google TensorFlow thing. It's actually doing all the work on its own. This machine is not connected to the network right now. No neural nets involved. So 1 plus 1, that's 2. Okay, that's easy. I can declare a variable. Let's say int I equals 0. No, 0 mark. I can write a little loop. Let's increment that. Okay, there we go. Now I is 10. Woohoo. Okay, so this is like not much more than a calculator. At this point, what's really cool about JShell is I can use it to explore an API. So let's say I've got a string. I'm going to make a string. The canonical example string. There's my string. If I type X and then dot and then hit tab, it will show me all of the methods I can invoke upon this string object. Now that should look familiar, right? Lots of useful methods. I can say, okay, suppose I want to take a substring, hit tab, okay, it completes, oh, wait, subsequence. Now I want substring, hit tab. Now if I hit shift tab, it shows me there are 2 overloads of the method called substring. One takes 1 int and the other takes 2 ints. So, and as you can also see, if you're paying attention, there's command history and all kinds of other command line-y goodness here. Substring 47, I get the string bar. Let me do something else with X. I'm going to split it. Let's say we'll split it on space, and what do I get back? I get back an array of 3 strings, foo and bar and baz. You might have noticed this $sign notation, $8 there. That's a pseudo variable. So I can type $8, and that refers to the value of that previous snippet. So let me convert that string array into a list. I'll type list string. L equals arrays dot as list. Complete that. $8. Now I've got a list. Okay, what can I do with the list? Well, I can do all kinds of things on a list. I can ask how big it is and stuff like that. One of the cooler things I can do as of Java 8, of course, is I can make a stream. So make a stream. Let's remind ourselves in there, foo, bar, and baz. Stream and say I want to filter that. Suppose I want to find just the strings that start with the letter B, right? Simple computation, no neural nets required. Filter, I'm going to type in a predicate, a little lambda expression. And note that even inside this lambda expression, it will do sensible tab completion. So s dot starts with is going to take B. Close that off, and I get some stream pipeline thingy that Brian wrote. I don't understand it. I just want to collect this back into a list of strings. So I go back in my history. I say collect, and I need a collector. So I'm going to go to the collector's utility class, if I can spell it. Collector, wait, no, I don't want a collection. I don't want collections. I want collector. The problem is it's not in scope. So I go over here and I import Java util stream star, and now collectors dot to say list, and Boom, barn does. There you go. So JShell, it's all about exploratory programming, right? For 20 years now, it's been the case with Java. If you just want to check something a little out and you're too lazy to go just reason about it from the Java doc, or you're in a rush, whatever, you create an x.java file or whatever you call it in your IDE, and you compile it, and then you run it, and then you change it, and you know, until you finally understand the API you're trying to work with. With JShell, you just start it up and type at it, and it shows you the results. It's incredibly useful. This is by no means meant to be a replacement for IDEs or other tools. It's rather it's a complement. It's not a debugger, even though in some ways it looks a little bit like a debugger. Okay, switching back here. Now, of course, I do have to talk about Jigsaw a bit, don't I? So Jigsaw has been this long-running project. We've been working on it for many years to solve an incredibly hard problem. We're trying to design a module system for the Java platform, which can be applied to the platform itself to make a modular, configurable platform, and which is also approachable so that you can use it with your own libraries and applications to escape from the brittle hell that is the class path. In the proposed design, modules it really comes down to two fundamental properties. Modules have reliable configuration, so a module names the other modules upon which it depends, so that at compile time and at runtime we can find all of the other modules needed to compile or run it, and avoid duplicates and conflicts and all the messiness that we find on the class path. The other critical property is strong encapsulation. So a module declares exactly which of its packages are exported for use by other modules, for whatever module might happen to depend upon it at some future time. Internal implementation details are finally something that we can truly keep internal, and this makes for more maintainable systems over time. So the module system in Jigsaw in 9 it's not a library or framework that just is sitting on top of the platform. It's actually deeply embedded in the platform itself. Modules are a fundamental new construct in the programming language. They're understood at a very deep level in the virtual machine. So let's take a look at that, and we'll go back to JShell to get started. So remember, we've got this string x. Okay, we're going to do a little reflection magic here. X. What class is X an instance of? Well, we all know what this is going to say, right? It's an instance of Java lang string. Well, in 9, with the module system, no, don't do that. With the module system, every class is loaded by a class loader into a specific module. So I can now ask of a class, what module is it in? So the string class is in a module called java.base. Java.base is the fundamental module in the system. It contains all the core things, Java lang object, Java lang string, the stuff that you just can't get on without, plus some other stuff besides that was too hard to separate out, frankly. There are a bunch of other modules. Let's make an object in some other place. Let's make a Java SQL timestamp. 0, whoops. Okay, the epoch, the beginning of time. So we know what its class will be. It'll be timestamp. That's easy. What module is it in? It's in the Java.SQL module. It's some other module in the system. In fact, there are a whole bunch of modules in the system. Let's break out of JShell. There are some additional options to the Java launcher. I can ask it what modules are observable, and I get back. Whoa! I get a whole long list. It's actually quite a long list, isn't it? There are 73 modules in a JDK 9 build. Let's take a look at some of those. So a bunch of modules start with JAVA because they define standard exported APIs that are supported, long-term, compatible, all of that good stuff. There are a bunch of modules starting with the letters JDK, which are for the most part implementation internals, or in some cases JDK-specific APIs that aren't part of the Java SE standard, but are actually things that you can use. So we see Java.base is up there. We've got scripting. We've got JShell itself is in a JDK-specific module. Management, everybody's favorite logging API, and of course Corba, because you can't live without that. Okay, so we've got all these modules. But of course, they're more than a list. Remember, every module names the other modules upon which it depends, except for the base module, because it doesn't depend on any. And that, of course, induces a graph. Whoops. let me get into the right directory since I had to reboot. There is the module graph. So this is the graph of just the Java modules plus one JDK module that's snuck in there for obscure reasons. This doesn't look as pretty as graphs I've shown before. There's a reason for that. The reason for that is this is generated automatically by the build. The build generates a dot file that is this graph, and this is just the rendering of that graph into a PNG. So we've got the base module down at the bottom. As I said, it doesn't depend on anything else. Logging depends on base, and security SASL depends on logging and base and all this other stuff. So you can see there's a very rich structure here. And it took a long time to get to this structure because, of course, the JDK grew up as this monolithic thing over 20 years where lots of stuff was connected to a lot of other stuff, and it took a lot of effort to decompose all that and make it sane. All right, so we have a module graph. We have a modular platform. What about code that exists today? Can I run code that exists today, or do I have to go change it? Well, it would sort of kill one of the fundamental values of the Java platform if you had to go change your code. In fact, if you have old code that uses only Java SE standard APIs, it will still work. Let me show you an example. Does anybody remember swing set? Swing set. George remembers swing set. He wrote the tooltips for it. So swing set was one of the demos in Java 1.2 originally to demonstrate swing. It was updated to swing set 2 in some release. This is an exact copy of swing set 2 from JDK 5 shipped in 2004, and I can run it. Ta-da! Oh, the good old days, swing set 2, the metal look and feel. Everybody remembers this, right? All this great stuff. It's excellent. We even have the famous bouncy babies. I think some of these kids are in college by now. So there we go. So old stuff continues to work. In some cases, it won't work. And that's usually when the old stuff is referring to JDK internal APIs that we've been telling people for 20 years not to use. So sorry. There are command line workarounds that will let you get back to those. A few of them are so popular, some is gun safe, that they're actually still there, at least for a little while. But anyway, so yes, the modular platform, it's modular, it's compatible, and another really cool thing is it's configurable. Remember, we've got this module graph, right? So given this module graph, we can reason about, well, what are logical subsets of the system? What if we wanted just a few modules and the modules that they need, and we wanted to like try to live without Corba and XML web services and stuff? Well, we can do that. There's a new tool. There's a new tool called JLink. Java finally has a linker, something I wondered about when I started working on Java 20 years ago. Where's the linker? Well, you didn't need one, Mark. It's dynamic linking, bozo. Well, we have a linker now. It's an optional build step, and you can use it to make your own custom runtime image. If you look in the JDK build, here's the one I'm using here. Whoops. The one I'm using here, if I can type. Yes. Right, it looks kind of familiar. There's a bin directory and an include directory and other stuff. And there's also this jmods directory right here. So in that directory are a bunch of jmod files. They're basically jar files on steroids. They contain classes and native code and other stuff that you need to build a JDK component. We can take subsets of those with JLink. So I tell JLink where to find modules by telling it the module path, j/jmods. To start off, I'm going to make a minimal runtime image. It just contains the base module. So add modules, java.base, output that into, say, JRE base. It will go off and do some computation. No neural nets involved. And I have JRE base, which is, it's smaller. It only contains a few things. If I ask how big things are, well, actually, let me do this. The whole JDK build is 513 megs. It's just big. JRE base, with just the base module in it, is only 45. And it has useful stuff in it. So JRE base bin Java list modules. It only has the base module. Well, that's good. That's what I asked for. If we can actually ask for the details, what's in java.base, and you can see it exports a fair amount of stuff. It has not just java.lang, but Java I/O and some annotation stuff and basic networking and new I/O and security. So you can actually write very useful applications just with java.base. But of course, some things you won't be able to do. For example, You can't run swing set. Why can't you run swing set? Well, because the swing classes aren't there. 2D classes aren't there because it's just the base module. We could, of course, make a custom image that contains the desktop module here, which has swing and AWT, and that's actually very easy. Let me do this. I'm going to make a desktop JRE. I'll ask it for java.desktop. I don't need to ask it for base because just desktop will pull base in for me. JLink that. How big are the results? Well, the desktop image is a little bit bigger than just the base image, but it's still way smaller than the entire JDK. And given JRE desktop, let's see, in Java list modules, we've got the desktop module plus a few others we didn't ask for. Now, why are those there? They're there because they're implied by the module graph, because the desktop module here says that it requires the prefs module and it requires the data transfer module, and the prefs module requires XML, and of course everything requires java.base, so that's why we got that other stuff. Now, there's one other cool JLink trick I'd like to show you. JLink has an experimental plugin API and a number of built-in plugins. With those plugins, you can do cool stuff such as compress the image that you're producing. So I'll go back to this JLink command. I'm going to make a compressed desktop image. So it's going to have the same content, but I'm going to compress the class files. I'm going to use a smaller VM that emits some of the serviceability features to save space, and I'll also strip the debug information. Whoop. Now, this is, of course, going to take a little more time because it's doing a bunch of compression, but still no neural nets. Go check Twitter. There we go. Whoops, no, not that. Do $J and Jerry star. Okay, the compressed desktop image is only 31 megabytes. It's smaller than the uncompressed base image. And of course, it's still perfectly capable of running our beloved swing set. By now, George is thinking, oh my God, just stop. Okay, that's the last we'll see of swing set. Goodbye, swing set. It's been lovely. Okay, so the modular platform, the platform is now modular. It's compatible, it's configurable, and it's also approachable. It's something that you can use. We've gone to some pains to make it, fairly easy to reason about, so that you can build complex systems out of it and understand what's going on. So I'd like to show you a very simple modular application. I'll crank up my favorite IDE here. It's called Emacs. I've got a data file. This is a file of tweets in JSON. So it's JSON. It's not particularly readable, but all the data's there. This is what you can get from the fire hose if you ask it nicely. I wrote a little tiny application to display this in a more tasteful form. It's called TweetSum, and it's got just a couple of classes. It's got a main class. Here we go. I'm using the Jackson libraries for parsing JSON and doing data binding. This is all pretty straightforward stuff. I make an object mapper. I configure it. I parse a list of tweets from system in, and then I print them in a somewhat more tasteful fashion on system out. Every tweet is represented by an instance of this class called tweet, logically enough, which has some annotations in it to identify a private field for timestamp and another private field, whoops, that's not good, for the text of each tweet. And any other JSON fields are just ignored. So I could compile the main class and the tweet class in the normal way, stick them on the class path, run it, and it would work, right? But we want to see how to make it into a little modular application. To do that, we need to write what's called a module declaration. Remember, modules are a fundamental new construct in the language understood by the virtual machine. We do a module declaration in a file called moduleinfo.java at the root of the package hierarchy of each module. In moduleinfo.java, I say I'm making a module. I'm going to call it TweetSum. And what do we need to know about a module? Well, remember, reliable configuration, strong encapsulation. For strong encapsulation, we would need to say, what are we going to export? Well, this is just an application module. It's not going to export anything. That's fine. We do need to say what other modules does it need. Well, to figure out what other modules it needs, let's reason about that a little. I'm going to say requires. I could say requires java.base here because we always need the base module. But in fact, since you always need the base module, if you don't say that, the compiler will insert it for you. To get going on this, let's look at some of our imports. That often gives you a good clue. So here we need to import, we're using the SQL timestamp class, so we're going to require that SQL module. We saw a little bit of that earlier. We also need, let's see, we've got these Jackson annotations. Jackson annotations, huh? What? Wait a minute, I don't have these in modules. I mean, all I've got here in my lib directory are these Jackson jar files. They're not modules, they're just jar files I got off Maven Central. They're actually from a slightly old release. They're probably never going to be converted to modules. I could go and convert them myself, but then I'm messing with somebody else's jar files, and that's kind of gross and hard to maintain. So the module system has a concept to help with this. Right? It's really important to be able to write modular applications that can depend upon components that have not yet themselves been modularized. So we do that with this notion of automatic modules. If you have a set of jar files and they're reasonably well formed, they don't have conflicting packages or classes or any of that ugly sort of stuff, you can take those jar files, put them on the module path, and the module system will synthesize module declarations for them at runtime for free. So in many cases, today's jars are just tomorrow's modules without any change. So that's actually pretty cool. So the names of the modules are derived from the names of the jar files. We even get the version information in there. So Jackson-annotations-2.6.6.jar becomes a module called Jackson Annotations, and so on for the others. So I can now go back into Emacs and write, let's see, I need Jackson Annotations. I'm going to need Jackson.core, because that's used in the main class, and I will also need Jackson.databind. Now, I'm almost done. I could compile this, and it would compile, but at runtime it would fail for a detail that's worth explaining. The tweet class, remember, has these private fields in it. The Jackson data binding library is going to go use reflection and the setAccessible method to break into those private fields to set them to useful values. We want that to happen, but by default, everything is strongly encapsulated. If we don't do anything else, then that will fail at runtime, but of course we want it to work. Right? Reflective frameworks are a fundamental part of life in Java. There has to be a way to make those work. So we have a concept of open modules. You can declare a module that a module is open. That means that its packages are available for such deep reflection at runtime, but you cannot compile against them. They're still completely strongly encapsulated at compile time. If you want to, you can open specific packages. In this case, I've just opened an entire module. All right, so we're finally ready to compile this. Java-C, just like the Java launcher, takes a module path. We're going to put in our automatic modules. Compiling a module is a little different than compiling for a class path. We're going to put the output in a directory called mods. I need to tell it where the module source path is. Source, and then finally, this is my complex IDE foo here. Well, let's just say. And that'll go off and compile. Oh, there we go. Now I've got mods. Unlike a classes directory, every entry in the mods directory represents an entire module, so it's named after the module itself. And if I look inside mods, I'll see I've got the main class compiled and the tweet class compiled, and the module info, of course, it compiles into a class called module info.class, which is understood by the VM and the runtime system. And now I can finally run this stuff. Module path lib, and of course I need to tell it where the modules are. I tell it what module to run. It's going to be the tweetsum module. Within the tweetsum module, I need to tell it where the main class is. So the main class is org.tweetsum.main, and I give it the input file, and boom, pretty list of tweets from a tiny modular application. So I can go further with this. I can make a custom linked runtime image if I hack around a little bit more, but time is short, so I will stop there. So I've showed you a bunch of stuff from Jigsaw. It's real. It works. It lives. It has some important essential features. It's scalable. The platform is scalable, the module system is scalable, the result is compatible, the system is configurable, and we're looking at the wrong screen. Sorry. Da-da-da. And it's approachable. It's designed for mortal developers to use. You can learn a whole lot more about it. We've got a bunch of JEPs in OpenJDK that describe the details. There's an entire JSR 376 for the module system itself. We are doing 3 sessions here this week, my colleague Alan Bateman and I. Introduction to Modular Development at 3:10 this afternoon. Advanced Modular Development, 9:30 tomorrow morning. And Project Jigsaw Under the Hood, a deep dive into the theory of the module system tomorrow afternoon at 3:10. So that's some stuff in 9, some stuff other than Jigsaw that's in 9. 9 is slated to ship in the summer. I'm reasonably confident in that date, but it is software. Let's talk about stuff later than 9, not in any particular release necessarily. And here's Brian Goetz to help us with that.
Hey, Mark.
Hey, Brian. So, what have you been hacking on?
So for the last couple of versions, we've been focusing mostly on big things like Lambda and Jigsaw, we realized that we also need to focus a little bit on some smaller
Sanding
features.
off the rough edges.
Yeah, sanding off the rough edges that just improve everyday developer productivity. And so looking at typical developer pain points, one of the biggest pain points that developers complain about all the time is, oh, Java is verbose, it's so much boilerplate. Oh, is there anything you can do about that?
Well, they kind of have a point.
Yeah, they do have a point. Yeah. They do have a point. And we've been ignoring it for a long time, and we should do something about it. So we've got a couple of small features coming up in the pipeline that hopefully should sand off some of these rough edges, and I'll show you 2 of them today.
Okay, what's the first one?
So the first one is about what I think is the biggest source of boilerplate in Java, which is simple domain classes.
POJOs.
POJOs. They're
right.
Dumb data carriers that...
Well, like I had in the tweets thing, private this, get this, set that other.
Exactly. So these have, to use my favorite phrase, an undesirable beef to bun ratio. Mm-hmm. And so if you have your typical domain class like this XY point, really you'd like for this to be the whole thing because that's really all the beef there is.
Yes.
But when you go to write this class, you also have to write a constructor and an equals and a hash code and a toString.
Right. And your IDE could write that for you, but then you'd still have to read it, which is like...
Yeah, reading code is more important than writing code. And so even though the IDE makes short work of writing it, that's still a lot of code to look at and say, oh, that's just an XY point. Mm-hmm. So it would be nice to be able to communicate to the compiler that I'm just a dumb data class, all I've got in is X and Y fields, and you would just automatically acquire all of these code artifacts.
Okay.
Like this. And so this is a possible syntax where you're saying you move the principal fields up into the class header, and you automatically get constructor equals status.
Now, what if you wanted some non-default behavior?
You just put them right in.
Okay.
Right.
Cool.
So then the only thing that you see is actual beef. So that's something that the author has decided is an important part of the class.
Mm-hmm.
Now,
excellent.
The devil's in the details, right? Because, if you want to tweak the behavior of equals or something like that, you don't want to have to rewrite the whole equals method.
Right.
So we've also got some other sort of smaller features that go below this to try to address that. And we're still working on that, but it should be a big help.
Okay. What's the second one?
All right. So the other one is expanding the scope of type inference. So we're big fans of type inference.
Lots of people still say Java doesn't have type inference. I'm sorry, you're just wrong.
It drives me crazy. We've had type inference since Java 5.
Yes.
But, so type inference is, we really like it because it allows you to eliminate redundancy from your code while maintaining the benefits of strong static typing. Mm-hmm. And so, we started with type inference in Java 5, inferring the types of generic method type parameters. So instead of having to explicitly say, string here when making an empty list of strings, the compiler just infers it. In fact, a lot of people don't even know about the first syntax because the inference works pretty much all the time here.
Yep.
And in Java 7, we decided to expand the scope of type inference to constructors with the so-called diamond feature.
Right.
So here, you used to have to explicitly say list of string, new array list of string, but we realized that there's no reason to have to say that twice. The compiler can figure that out, and so we allowed that.
Yep.
And so, we kept going. In Java 8, when we added lambda expressions, you could have the types of a lambda formals be explicit, Or you could have the compiler figure them out for you from context, and most of the time it can.
I don't think I've ever typed a lambda and had to declare the...
You do it once in a while. Sometimes you need to, but most of the time you don't, and it's perfectly readable. And so we think the sort of next obvious place to apply type inference is local variable declarations, right? And so, if I've got a bunch of local variables here that where I've skipped a little bit. Here I declare a local variable reader. I say it's a buffered reader, but the compiler can well figure out that it's a buffered reader. And so, we've adopted the convention that some other languages have done, which is to say var, which means figure out the type for me. This isn't dynamic typing. It's still strong static typing.
It's not JavaScript?
It's not JavaScript,
okay,
no. The compiler is just synthesizing a type from what's on the right-hand side and saying that's the type of reader.
Okay.
And, with a longer example, it actually reads pretty nicely. And some people, ask, doesn't this make the code less readable because you're
well, it will if you
type
don't have any taste.
If you pick lousy variable names like X, Y, and Z, it will make your code less readable. But in fact, I claim that this is more readable because the most important thing here is the variable name, not the type. And by moving the variable names front and center, it's a little bit more obvious what's going on in this code.
Yeah, excellent. So these are two fairly small things. I have to ask Stefan, can we go a couple more minutes? You don't want us to stop? Okay. We're going to keep going.
Okay,
we have permission from the master.
Excellent.
Thank you. Okay, so those are some cool small things. Let's look at some bigger stuff that you've been working on.
Yeah, absolutely. So for the last couple of years, we've been working on two big projects Valhalla and Panama. I'm going to be talking a lot more about these at the Java Sneak Peek talk on Friday morning, so come to that if you're interested. Project Valhalla is about two major features, value types and enhanced generics, which is both a performance feature and an expressiveness feature. And Panama is about rebooting the JVM's interaction with native code and native data to make it easier for Java code to call native code and access data in the native heap.
Okay. So I think you have a Panama demo, right?
We've got a demo, yes.
Okay.
It's actually
you want to explain what the demo is first?
Sort of a machine learning demo. Okay.
Does it have neural nets?
I believe it does.
Does it need a network connection?
No, it doesn't.
Oh, good.
We took the we wanted to have an example of a native library that we wanted to just be able to use from Java and show how easy it was. So we took the Opencv library. Now this is a C++ library for image processing. So it has all kinds of useful image manipulation stuff, including image classifiers. So we configured it to detect cats in images.
Cats?
Yes, because the internet is full of cats.
Well, that's what the internet's for.
That's what the internet is for.
Okay.
And so we wrote pretty simple C program to call Opencv, and we actually got the code up here. It's less than a page of code. The details aren't important, but the basic idea is you read an image in from a file, and then you pass it to the image classifier, and it hands you back a bunch of rectangles. You draw the rectangles on the image, and then you redraw the image.
Well, that's reasonably straightforward.
Right, and so we want to make writing this code to call this native library as easy to do in Java as it is in C.
Okay, but people already do this with JNI today, so why do we need Panama?
Well, the very brave ones do it in JNI.
Yeah, I guess there's that.
JNI is miserable to use, but in return for that misery, it's also unsafe and slow.
Whoa! 3 benefits in one tiny package.
Exactly. So, the goal of Panama is to make calling native code as easy, safe, and fast as calling any other Java library.
Right. Okay.
So, and to give you an idea of how painful JNI is, I wrote out the JNI code. The screen's not big enough. But this is the handwritten Java stubs, for basically calling the API points in that that are used by that previous program. And actually, there's more. Then there's the handwritten C implementations. So this is what you would have to do to write that little program in JNI. And this is what you do to write it in Panama. And it looks almost.
It looks like the C code.
It looks almost exactly like the C code.
Cool.
And when you access things like when it hands you back pointers to rectangles and things like that, and you call getters to access it's accessing it right out of the native heap. It's not marshalling the data into the Java heap. It's just going directly.
But it's
to the
doing all
heap.
this safely.
And it's all doing all this safely. It's really cool.
And it actually works. You want to show us?
Yeah. Let's have a demo.
Switch to this machine.
All right.
Type the magic command.
The magic command. Okay, so
there we go.
Do we have a mouse here? Do we have a mouse here?
No, it's this guy.
It's that guy.
Yeah, sorry.
All right. Okay, so we have a bunch of cats to demonstrate that yes, in fact, it does detect the cats. More cats.
You can just use the down arrow to go down.
Oh, okay, even better.
Even better.
Yeah, not exactly a cat, stone
No,
cat.
it's a
It didn't fool
large stone feline.
Yes,
Okay.
didn't fool the
Didn't fool
detector.
that. That's good.
Yes, that's a real cat.
Uh-huh.
That's a real cat.
Hey, that's my cat.
Yeah, you should be careful what you post on Twitter.
Jeez.
That's
your cat.
That's my cat. And that's Oracle CEO Safra Cats.
Not a cat.
Not a cat. And the cast of cats.
They're not cats either.
Also not cats, and the detector wasn't fooled by this.
Okay.
And so this is just a simple JavaFX program wrapped around that little bit of code I showed you before.
Okay. Back to slides.
So,
Okay.
so the way this all works is really cool. It replaces the whole JNI workflow with, which is full of handwritten, error-prone stuff. Like if you're writing a JNI program, you have to do all of these things, and each of these steps is manual. Each of these steps is error-prone, and something.
And the result is unsafe and dangerous.
And the result is unsafe and dangerous,
So,
even if you get it all right.
yeah.
So it's total win. Instead, what we do is we replace this with a tool-based workflow where you point this tool at your C header file. It extracts metadata that describes the calling format and the layout of structs, generates Java interfaces that you can call just like a Java library, and then at runtime it generates Java code to bind to it. And so that way, all the code, the VM is able to see through this whole stack of stuff, your call to the interface, the generated code, the Panama runtime, and so it's able to optimize all the way through it.
Excellent. Okay.
So, very cool.
Thank you very much, Brian.
Yep.
Great
thank
stuff. Looking forward to it. But not going to tell you what release it's in.
Someday.
Because we don't know. Okay. Last thing, we need you. The Java does not move forward without lots of feedback, both early and late. You can get JDK 9 builds. You've been able to get them for a couple of years now. You can still get them, jdk9.java.net. If you really want to live on the bleeding edge, you can get the even earlier access Jigsaw specific builds. You can find those off of the project Jigsaw page. Brian and I work for Oracle, so you should not believe a word that we say. Thank you very much.
Thank you, Mark. Thanks. Great. Thank you, Mark. So wrapping up, our last keynote speaker, it's been a speaker that I've been really looking forward to actually get into the DevOps circuit. I'm really excited for the next speaker. He was willing to do